on my page, it is the bottom of page 17. Looks like on yours it's the bottom of page 16. Okay? So I'm going to scoot this up. We need to simplify the square root of 5 times the square root of 48. Now, what can you tell me about 5, just in general, with what we've been doing? It's odd, yes. What else? Isn't 5 a prime number as it is? So if we divide by that 5, we would just get 1, okay? So this 5, if we were to do anything with it, and we do that cake method, okay, whoops, it's not a radical, it's just division. Divide by 5, you get 1. So this is simplest form already, okay? Simplest form already. We don't need to do anything with that. We do need to use the cake method on 48. So let's do that with 48. Put it on the bottom layer. 48 is what kind of a number? Stephen? Even. So that means it's divisible, Aiden, by 2. Very good. So divided by 2. 48 divided by 2 is 24. Johan, 24 is what kind of a number? Even. So divide that by 2. We get 12. 12 is even, divided by 2. You get 6. 6 is even, divided by 2. We get 3. 3 is not even, but I know I can divide it by 3 because that is a prime number. You are always only dividing by prime numbers. And 3 divided by 3 is 1, so I know I've reached the top. These are all of the prime factorization for 48. So I'm going to rewrite this. Cannot walk and write very well. So I rewrite it as 2 times 2 times 2 times 2 times 3. And then we also have this square root of 5. Now, since that is under the radical, I can just move that back here to the end. Okay? Because it's under the radical. Then I'm going to circle my pairs. I have a pair of 2's. I have a second pair of 2's. I'm going to kick those out. And I have 2 times 2 out in front. This 3 and this 5 do not have another pair, so I just multiply those together and keep them under the radical sign. So my final answer is 4 times the square root of 15. Questions on that? All right. Let's go to the next side. This says simplify the square root of 8 times the square root of 14. See if you can try that one on your own. Square root of 8 times the square root of 14. I got it. Thank you. Try that on your own. Raise your hand if you need some help or hint. If you're not sure. Now, if it doesn't divide evenly, then we can't use that. Okay? So 3 is not going to work because it didn't go in there evenly. I need a whole number. So 2, 3 doesn't work. 5 doesn't work. Do you know what the next highest prime number would be? Check back. Put back in your notes. Because we talk about 2, 3, and 5 a lot, but the next one is 7. Okay? Yeah. You're right. It doesn't. So, and it's not even, right? It doesn't end in a 0 or 5, so I can't divide by 5. Check back here and look at your prime numbers. What's the next prime number?
11.
Well, it's 7. So yes, we can divide by 7. It's just we focus on those first 3 because usually they work. How are we doing? Gotta write it down. Start with the bottom layer. 8. If 8 is even, what can I divide it by?
2.
So put 2 on the outside. And this is not a square root. This is just a dividing bar. It's like long division. Okay, 4 is even. Divide by 2.
What about 2?
Well, you got to put the 2 over here. So do the division bar again. This is like our layer of cake. 4 is good. Just put a 2 on the outside over here, just like you did. Long division bar, and then a 2 over here. And 4 divided by 2 gives you,
2.
Do a long division bar there. Put 2 on the outside. 2 divided by 2 is 1. So this is your prime factorization. That's what we need. Those all together get this part. Now you have to do the same for this. All right. So, here we go. Square root of 8. Okay, very close. So 8 is even. Divide that by 2. You get 4. 4 is even. Divide by 2. You get 2. Divide by 2. You get 1. So this is your prime factorization. And you would rewrite 8 as 2 times 2 times 2. And we could pull that out, but I know I'm going to have some other numbers over here. So I look at 14. 14 is even. Divided by 2, I get 7. And some of you were stuck here because we've primarily talked about 2, 3, and 5. 7 is not even. It doesn't end in a 0 or 5, so I can't divide by 5. It is not divisible by 3 because I don't get a whole number. But 7 is the next prime number. So we can divide by 7, and you would get 1. So the square root of 14 is 2 times 7. So I can almost erase this part and make it all one long bar, and then find your pairs. I have a pair of 2's. Here I have a pair of 2's, one from the 8, one from the 14. Only one out of those pairs comes out, so that's 2 times 2 out in front. This 7 is the only thing that doesn't have a pair. That stays underneath, so my final answer is 4 times the square root of 7. Did anybody happen to have that for an answer? Very nice. If you didn't, do you see why this works now? Okay. Does this make some sense? No? Can you tell me where it doesn't? Do you understand how to get the prime factorization? No? If you have an even number, you always want to try to divide by 2. Okay? We only want to divide by our prime numbers. And if you go back in your notes, we talked about the prime numbers right here as 2, 3, 5, 7. Most of the time we only use 2, 3, and 5, but today we use 7. So if it's an even number, keep dividing by 2 until you get to a 1 at the top. Rewrite these numbers, and then you're trying to look for pairs. You circle the pairs. Okay? That was just for 8. Then we did the same thing for 14. All right? Does that help a little? Not at all? All right. Well, we've got D lunch. You can come over and I can try to explain it if you'd like. This keeps going. I'm going to erase all this now. Then it says I have y to the 4th. That is an even amount. And so if I want to find the square root, divide your even number by 2, and it rewrites it as y squared times y squared. So I'm going to put that over here. Y to the 2nd times y to the 2nd. Now we go back and we circle our pairs. Circle the ones that are common. Well, I have 2 5s. I have 2x to the 1st. I actually have 3, but I can only circle 2 at a time. I have 2y to the 2nds. So all of those are going to send one of those members out in front. So that's 5 times x to the 1st times y to the 2nd out in front, because those all had double partners. The only thing that didn't have anything doubled was this 2 out in front and this x to the 1st. And so this is your final answer. And you can write that as 5xy squared times the square root of 2x. Either one of those I would take. Okay? All right. And we get another chance to do this type of problem. So now let's look at letter B. So if you didn't get it the first time, let's try it here with letter B. Let me clean this up a little bit. Okay. So first of all, we're looking for the square root of 20a squared b c to the 3rd power. All right. First of all, let's deal with 20. 20 is an even number, so divide by 2. You get 10. 10 is even. Divide by 2. You get 5. 5 is not even, but it is divisible by 5, and you get 1. So my square root of 20 is 2 times 2 times 5. I'm going to write a squared over here. A squared. That is an even number. If you have a variable with an even number, divide it by 2. Divide that 2 by 2, and that gives you a to the 1st times a to the 1st, because 2 divided by 2 is 1. Okay? Isabel, are you with me? All right. Then I have a single b. That's a b to the 1st power. It is odd, but I mean, there's nothing else with it. So I'm just going to leave b to the 1st as b to the 1st. Okay? And then finally, I have c to the 3rd power. That 3 is odd. I want to change that. So I'm going to change it to c to the 1st. And when I take 1 away from that 3, that leaves me with c squared. Now this c squared, that's even. I need to change that, so divide that by 2. This c squared is going to become c to the 1st times c to the 1st. So all of these would be, oh, I forgot to write them down each time. The first one is going to be a to the first times a to the first. I have one lonely b, so I'm just going to put b to the first. And c to the third I broke down as 1c, and then I broke c squared into two other ones. So I have c to the first times c to the first times c to the first. Because remember, when you are multiplying these together, you add the exponents, and those added together add to 3. Circle your pairs. I have a pair of 2's, I have a pair of a's, and I have a pair of c's. 1 comes from each group out to the front, and you've got 2 times a to the first times c to the first. Anything that didn't have a pair stays multiplied under the radical sign. So that's 5, b to the first, and c to the first. This is your final answer. Or, because of all those ones, you could also write it as 2ac times the square root of 5bc. Right there. How about one more example? Does everybody understand it? I'm not convinced. I'm just going to do this one on the whiteboard, okay? So if you don't want to write it down, that's on you. If you feel you understand it, that's great. If you want to do this one yourself, I'm going to do one more example. All right. So here's the one more example. Is anybody going to watch? Is anybody going to copy this down? Or am I doing it for me? I'll do one more. So I want the square root of 20, let's say x to the 7th, y to the 3rd, z. Okay? 20, x to the 7th, oh wait, I don't want that. Why don't I want that? Because one of them is not even. Let's make that 3 a 4.
This is 1 or 7. This is 1 or 7.
That's a 7. 7. I'm just making up this problem as an extra problem to do. You can write it down in your notes, or you can just watch. Okay? So 20. I'm going to use the cake method. That is even. So I can divide by 2, and I get 10. 10 is even. Divided by 2, I get 5. 5 is a prime number, so I can divide by 5. There's my candle. There's my prime factorization for 20. Okay? So I'm going to rewrite 20 as 2 times 2 times 5. All right. Now I'm looking at my variables. X to the 7th power. I am going to rewrite that as x to the 1st times x to the 6th. So this is odd. If you have an odd number, take 1 away. That's why I rewrote it as x to the 1st. And 7 minus 1 gives me the 6. Now this is even. Anytime you have an even exponent and you're trying to find the square root, divide this by 2. So this is going to break down into 6 divided by 2 is 3. And so I have 2 of these that are 3. X to the 3rd times x to the 3rd. So I am rewriting x to the 7th as x to the 1st, which is right here, times x to the 3rd times x to the 3rd. And remember, I have to add the exponents. 3 plus 3 is 6 plus 1 is 7. So it equals the same thing, right? So now I have y to the 4th. I'm going to rewrite that by dividing by 2. That's an even number. And y to the 4th divided by 2 is going to be y to the 2nd times y to the 2nd. Because 4 divided by 2 is 2. So over here, times y to the 2nd times y to the 2nd. Finally, I have z. Z, there is only 1. There is nothing matching with that. So I'm just going to leave that as z. Okay? And this square root bar would go over all of these. Would end right here. Right there. Circle your pairs because you're trying to find the square root. So here's a pair of 2's, here's a pair of x to the 3rds, here is a pair of y squares. All of those come outside and out in front. So I have 2x to the 3rd y squared times the square root of everything that did not have a matching pair. That is 5x to the 1st and that z to the 1st. So this is your final answer. Or if you don't want to write the 1's, you can write it as 5xz. Okay? Questions on that? And remember, a square root means you are trying to find, if this is the area, okay, 20x to the 7th, y to the 4th, z, the square root is what is the length of one side of that square. That's what you're trying to find. And the answer is this. 2x to the 3rd times y squared times the square root of 5xz. If I take this times itself, you should get that perfect square number, this right here, as your answer. That's what a square root is. This is your perfect square. This is your square root. All right. Stick a fork in me. I am done. About time. All right. So homework 3. Remember homework number 3. Due on Friday. Now you can also do that weekly Canvas activity. 1013. That is due on Friday also. Okay? So be working on those 2 things. If you haven't gotten homework 1 or homework 2 done, I've got extras over here also. All right? Okay. Any questions for me? Yeah. You still want to go over some stuff? Yes? You want to go over some stuff? Yes? Okay. Amani, do you want to go over some stuff still? No. You want to go over some stuff? Yes or no? Okay. Give me a minute. I don't have you using any. Is that possible? Maybe? And when is the test for this chapter? Next week on Tuesday. Okay? There you go. All right. If you are still feeling a little stuck and not understanding all this, I'm going to be working with a couple of people over on that far whiteboard over there. If anybody wants a little bit of extra help. Okay? All right. Plug this in. Plug this in. Santana, are you getting everything? Does this make sense? Well enough? Ready right now? Well, we got one more small thing to learn. Does this make sense? Okay. Does this make some sense to you? All right, so I'm going to be doing some simple work here. Right, bring your stuff. Bring the paper, bring your stuff. All right. So I will be here tonight after school. Okay. Always want to put the decimal between the first two non-zero numbers. So where are my first two non-zero numbers? 2 and 6, right? So I'm going to put the decimal right there. Right now, since this is a whole number, it usually is here. But we're putting the scientific notation. This is where it is now. This is where I am putting it. I am putting it. So I know it's something times 10 to some power. Okay? I am putting this one here because when a number between 1 and 10. We put it in between the first two non-zero numbers. This number is 7.8, 27, and the next highest number is 8. Now, we are going to the left to where it was originally, where it is now, before I moved it. So I'm going to the left. Since you're going to the left, that makes it a negative because it's small. So I'm going 1, 2, 3, 4, 5 places to the left, or you can look at it as moving it from one place here. Now that you've cleared all your numbers, 1, 2, 3, 4, 5. So let's take a look at the first number that you got. Here's the largest. Right? $65 billion. Alright, so I'm going to rewrite this as a number between 1 and 10 times 10 to some power. What number is going to be 10? Got it? 6, my only non-zero number. So is it 65? 25, yes. Okay, so again, Tesla wants to go in between those two. This is where we are putting it now, right? This is where it is originally. Now, I'm going to the right from where I'm putting it. This is scientific notation. Back to where it was originally. I'm going to the right. Is that going to be a positive number or a negative? Positive. And how many positions do I move it to go to the right? 1 here, and I have 3, 6, 9 zeros. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that answer is 65 times 10 to the 10 power. We can put the positive there, or we can use the problem number 2. Scientific notation. So here we see where the decimal point is, but I need to move it to put it as a number between 1 and 2. Oh, so that makes it 2. Okay, gotcha. Perfect. Yes. So, what is this number? It's supposed to go in between the first two non-zero numbers. There's a problem. You only have one non-zero number. So, So, what are some of my like terms here? In, and remember these two together, those are my coefficients out front, right? What else is a like term? The x's. So I'm going to put x to the fourth. And this is times. This is all being multiplied, right? Because there's no other sign. So there's no sign to multiply. What is this x? X to the, oh, there's nothing there. So put a 1 on it, right? That's x to the first. And then I have All right. Thank you. Thank you. Oh my.